So in this video, we're going to begin discussing the general multiplication rule. These are things that happen at the same time, the ands for us. And to begin with, the probability of event A and B happening at the exact same time is equal to the probability that A occurs times the probability that B occurs given that A occurs. So we have that given portion again that we've already discussed in the previous video. So let's look at example 3. The probability that a driver who is speeding gets pulled over is 0.8. So we know that the probability of speeding and pulled over is 0.8. The probability that a driver gets a ticket, given that he or she is pulled over, so probability of a ticket, given they are pulled over, is equal to 0.9. What is the probability that a randomly selected driver who is speeding gets pulled over and gets a ticket? So we want the probability of speeding / pulled over and gets a ticket. So we have this and here. So we have the probability of speeding with a ticket, or I'm sorry, with pulled over. So the probability that they get pulled over. And we're going to multiply that by the probability of receiving a ticket given they are pulled over. So ticket given pulled over. The probability that they were speeding and pulled over was 0.8 times the probability of a ticket given they were pulled over is 0.9. So the probability that they were speeding and was pulled over and gets a ticket is going to be 0.72, 72 hundredths. So there's a probability of 0.72 a driver who is speeding gets pulled over and gets a ticket. Now, we need to talk about a concept called independence. Sometimes the occurrence of one event has no effect on the probability that another event occurs. So let's think about drawing a card from a deck of cards. So if a card is drawn, then put back, and a second card is drawn, and a second card is drawn, notice that we put the first card back. So the outcome of the first does not affect the outcome of the second. So it does not affect the outcome of the second draw. If you think about it, think about your deck of cards. You have 52 of them. You take one out, you look at it, you put it back in. You still have 52 cards to draw from. If for some reason you draw one card, take it out, and you want to draw a second card but do not put that first card back into the deck, now you only have 51 cards to draw from. That changes the probability, which also means that they would be dependent. They are independent if the probability stays the same. We don't want to confuse independent events with mutually exclusive events. Two events are independent if the occurrence of one does not affect the probability of the occurrence of the second. Again, drawing one card, putting it back, drawing a second card. Two events are mutually exclusive if the occurrence of one makes it impossible for the other to occur. Think about drawing a 3 or an 8. These two things are mutually exclusive. If I draw a card, it cannot be a 3 and an 8 at the same time. So being a 3 or an 8 is considered mutually exclusive. So let's look at independent versus dependent. We want to toss a coin, and then we want to draw a card from a deck. Does what happened with the coin affect what happens with the deck of cards? No, they're two separate items even. So these items would be independent. Drawing a ball from an urn, not replacing it, and then drawing a second ball. Let me draw an example. Here's an urn. I have 4 red balls. I have 2 yellow balls. And I have 3 green balls. Okay. If I draw one out of here, let's just say that it ended up being a red one. So that means now I only have 3 because I'm not going to put it back. I have 2 yellow ones still, and I have 3 green ones still. Notice, in this particular case, I had a total of 9 balls to draw from. Now, I only have 8 balls to draw from. I don't have the same sample size. So in this particular case, these items are dependent because I did not replace it. Okay, this one's a little bit more difficult. Smoking excessively and having lung cancer. So the question is, does smoking excessively change our probability at having lung cancer? You have one person that has never smoked and one person that smokes excessively. Just looking at those two characteristics, does one person have a higher probability of having lung cancer than the other? Yes, because we know that smoking could possibly lead to lung cancer. Not always, but it has a higher probability. So these events are dependent. Okay, having a large shoe size and having a high IQ. Does our shoe size have anything to do with our thinking or our intelligence? No, it doesn't. So this is actually independent. Because I can have a really small shoe size and a really high IQ, or I can have a really small shoe size and a really low IQ. So these two do not affect each other. The reason why we want to look at items that are independent, the formula or the notation for dependent is this right here. They're dependent on each other because notice it has a given and this changes my probability. When we have independent events, let me scroll up, this changes to the probability of A times the probability of B, because it doesn't matter what happens whenever I get A, or the first event, it does not change the probability of my second event. Let's look at example 5. A coin is flipped and a die is rolled. So we have the probability of a coin being flipped, and then we have the probability of a die being rolled. So find the probability of getting a head on the coin, so a probability of a head, and a 4 on the die. Well, flipping a coin and rolling a die, they don't change each other. My probability for rolling the die is always going to be 1 out of 6. My probability for flipping a head is always going to be 1 out of 2. So I'm going to have 1/2 for the probability of the head times 1/6 for the probability of the die. I multiply those together. I'm going to multiply straight across and I get 1/12. Or if I get the division, it's going to be 0.083. So the probability of getting a head on the coin and a 4 on the die is 0.083, 83 thousandths. So you really need to pay attention to whether something is independent or dependent. It will kind of change how you work the probabilities, whether you have just the straight multiplication or if you need to look at that conditional probability. Go ahead and practice identifying whether items are dependent or independent, and then try some of these multiplication rule and let me know if you have any questions.